Today we're going to be exploring 0 and negative exponents. So 0 as an exponent, for every non-zero number, a to the 0 power equals 1. So whatever our base may be, if it's raised to a 0 power, it will always equal 1. For a negative exponent, for every non-zero number, a, and integer n, a to the negative nth power will equal 1 divided by a to the nth. So let's use those properties to simplify each of these expressions. So here we have negative 3 raised to a negative 2 power. So that means we want to write the reciprocal, which is 1 divided by negative 3 raised to a power of positive 2. So that means we're taking negative 3 and squaring it. And negative 3 squared is negative 3 times a negative 3, which is a positive 9. 2 raised to the negative 6th. In order to get our negative exponent to be a positive, we need to find the reciprocal. So it's 1 divided by 2 to the 6th power. If we do 2 to the 6th power, it means we're taking 2 and multiplying it 6 times. So 2 to the 6th power is 64. Here, if we have 1 divided by 3 to the 0 power, well, 3 to the 0 power equals 1, because anything raised to 0 is 1, and 1 divided by 1 equals 1. So here we just have 3 raised to just the first power, and a, but now b to the 0 equals 1, so 3a times 1 is just 3a. If we have 1 divided by x to a negative 7, to find the reciprocal, be x to the positive 7 divided by 1, which when we reduce that down, x to the 7 divided by 1 equals x to the 7th. Here we have x to the negative 5 times by y to the negative 7th. So if we take the reciprocal on both, x to the negative 5 should become x to the positive 5 in the denominator, as well as y to the 7th. Here we have 8 divided by 2, but we want to make sure our c to the negative 3 becomes a positive. So instead of being in the denominator, we're going to move it to the numerator. And then 8 divided by 2 is 4, so it says 4c to the 3rd power. 9 to the 0 power is 1. Y to the 7th, so it's already a positive, so we don't need to change that. But to make this into our positive exponent, it becomes t to the 11th in the denominator. And 1 times y to the 7th is y to the 7th. And it's still divided by t to the 11th. Here we have 5. S to the 0 power is 1 times t squared, all divided by 2 to the negative 3rd now becomes 2 to the positive 3rd in the numerator, and m squared stays in our denominator. So if we simplify this, 5 times 1 is 5 times t squared, and 2 to the 3rd power is 2 times 2 times 2, which is 8, divided by m squared. So to simplify it one more time, since we're doing 5 times t squared times 8, we need to multiply 5 times 8, so 40 t squared divided by m squared. For these next two examples, we want to complete each equation. So if we have 4n, we want to figure out what the power is. So then when we simplified this, it became 4 divided by n squared. Well, since right now n squared is a positive, this was a negative 2, and it moved down into the denominator in order to get our positive exponent. So for this next one, if you notice over here in our final answer, we don't have our variable a. So a had to have been raised to a 0 power, because a to a 0 equals 1. And since 3 is still in our denominator, nothing happens with our 3, but now b is a positive 3, so that meant b was raised to a negative 3 in the original problem. These next three problems, you're going to evaluate each expression for when r equals a -3 and s equals 5. So if s equals 5, it means we take 5 raised to a -2 power. So we want to simplify that to be 1 divided by 5 to a +2, and 5 squared is 25. So for our next one, we have -r, and r is a -3 raised to a -2 power. So in order to simplify that, we have our negative, but now we want to take our -2 power. So we have -3 raised to a +2, and -3 raised to a +2 is 9, so it's -1/9. And the last one of this type of problem, we have 5 times by -3 raised to the 3rd power times by s, which is 5, raised to the -1st power. So 5 and the -3 to the 3rd power doesn't change, but our 5 to the -1st becomes now 5 to the 1st power in our denominator. So in order to simplify this, if we take -3 and raise it to a 3rd power, we have -27. So 5 times -27 divided by 5, because 5 to the 1st is 5. And here, 5 divided by 5 is 1, so our final answer is -27. These last three, we want to write each number as a power of 10 using negative exponents. So here we have 10, and since it's a power of 10, this is really 10 to the 1st power. 10 to the 1st power is 10. So in order to write it as a negative, this is really 10 to the -1st. Here, looking at a power of 10, it's really 1 over 10 squared, because 10 times 10 is 100. So to use it writing the negative exponents, that means I have 10 to the -2 power. And for our third one, we want a base of 10, 10 to the 3rd power, because 10 times 10 times 10 is 1,000. But writing it into a negative exponent means we have 10 to the -3rd power.